In this lecture, we will understand EMF equation of transformer. A transformer works on the principle of electromagnetic induction. Electromagnetic induction. Electromagnetic induction. When alternating current flows in the primary winding, it produces a changing magnetic field, magnetic flux, so which produce an EMF or voltage in both the primary and secondary winding. So let's define some terms like N1 is the number of turns in primary, number of turns in primary. Then N2 is the number of turns in secondary. Then phi m is the maximum magnetic flux, that maximum magnetic flux. And then F is the frequency, E1 is the EMF in the primary, and E2 is the secondary EMF. So in the principal operation, so this is the diagram, like diagram of a transformer, 2D diagram of a transformer. So here, so this is the primary voltage, primary EMF, and this is the primary turns, secondary EMF, and secondary voltage, and this is the primary current, secondary current. This is the primary side, and this is the secondary side. So when AC voltage is applied to the primary winding, a sinusoidal alternating flux phi is set up in the core. This phi is equal to phi m sin omega t. So this time varying flux links with the windings and induced EMF according to the Faraday's laws of electromagnetic induction. Faraday's law of electromagnetic induction E is equal to minus n d phi by dt. So where E is the instantaneous induced EMF? E is the instantaneous induced EMF. N is the number of turns, and phi is the flux in Weber. Okay, let's see the derivation of EMF equation. So let phi is equal to phi m sin omega t, then d phi by dt is equal to phi m omega cos omega t. Hence E is equal to minus n d phi by dt is equal to minus n omega phi m cos omega t. So for the maximum value of EMF, so E max is equal to n omega phi m, since omega is equal to 2 pi f. So we can write E max is equal to 2 pi f n phi m. RMS, the RMS value of EMF is E max is equal to, so RMS value of EMF is equal to E is equal to E max by root 2. E max by root 2. So we can write 2 pi f n phi m by root 2. So E is equal to 4.44 f n phi m. So this is the EMF equation, general EMF equation of the transformer. Now for the primary winding, for primary winding E1 is equal to 4.44 f n1 phi m. For secondary winding E2 is equal to 4.44 f n2 phi m. As frequency of the primary and secondary both, so that this frequency is same, even that same flux is linking in the primary and secondary. So only that number of turns will be different. In the primary it will be n1 and for the secondary it will be n2. So this is the transformer equation, general transformer equation, and this is the transformer equation for the primary, and this is the transformer equation for the secondary. See the voltage ratio or transformation ratio. Transformation ratio we can write E2 by E1 is equal to N2 by N1 is equal to K. So this somewhere K is the transformation ratio. This K is the transformation ratio. If K greater than 1, so this is a step up transformer. If K less than 1, step down transformer. This is all about EMF equation of the transformer and the voltage ratio or transformation ratio of transformer. Thank you.